The simplest functional groups are the hydrocarbons. So hydrocarbons contain just hydrogen and carbon. We're not going to have any oxygen. We're not going to have any nitrogen or other elements. So of the hydrocarbons, they're going to put them into three different categories. First are the alkanes. And the alkanes consist of just single carbon-carbon bonds. And if you remember, our single carbon-carbon bonds, these are sigma bonds. And there are also hydrogen atoms in here. And of course, those hydrogens are attached to carbon, so there are CH bonds as well. So a simple structure would be this. This would be pentane. That's really a nomenclature. We're not learning nomenclature yet, but that is the name of that molecule. It's just an alkane. It consists of just single carbon-carbon bonds and hydrogen atoms. And of course, these can be in rings. This is a 6-carbon molecule. It's called cyclohexane. Again, that's more nomenclature, which we'll hit later. But that's what those are. Okay, the second group for the hydrocarbons are alkenes. Alkenes may contain single carbon-carbon bonds, but they also contain double carbon-carbon bonds, at least one, as well as hydrogen atom CH. So a double bond is a sigma plus a pi bond. You can write those in Greek or out in words, doesn't matter. What's an example? Here's an example of a structure. So this is a 4-carbon molecule. There's a carbon there, carbon there, carbon there, and carbon there. And these end carbons only have one bond to another carbon, so they have 3 hydrogens. We're not showing them in line angle notation, but there are 3 hydrogens there. These carbons have 3 bonds to a different carbon. So this carbon is bound to that carbon as well as has 2 bonds to that one. So this just needs one more bond to complete its octet. So I'm going to draw in the hydrogen. It's optional, but there's just one hydrogen on that carbon. And of course, we can draw our ring with the double bond as well. Okay, lastly, our third hydrocarbon group, these are going to be the alkynes. And alkynes will contain at least one triple carbon-carbon bond. Let's see a quick example of that. Here is a structure where this carbon-carbon triple bond, that is our alkyne. Now, this is not a true line angle structure. I mean, it's a valid structure, but I've put in more information than we have to have. Sometimes alkenes are kind of hard to communicate with as line angle structures. I'll take a stab at it. Normally, people put a little gap to show that, oh, this is a carbon, there's a carbon that has 4 bonds, 3 bonds to one carbon on one side, and then just 1 bond to the other carbon on the left, and there's carbons 3 and 4. So these two are the same structure. One is truly the minimal line angle structure. Now, these are 3 different types of the functional groups. You can have alkanes, alkenes, alkynes, and you can even have multiple functional groups in one molecule. So here's a molecule that contains both an alkyne and an alkene. So just as cars have parts and multiple parts, molecules can contain multiple functional groups. And that's just fine. And if you want to refer to this molecule as an alkene, that would be fine. If you want to call it an alkyne, that would be fine as well. If you want to say it contains both an alkene and alkyne, go for it. But there are, multiple ways to describe things. To describe these molecules that contain functional groups, but almost all of our molecules are going to contain some type of hydrocarbon group, because that's what you typically encounter most frequently in organic chemistry.